This is my example of a titration calculation. First, we are going to look at the information we are given. A 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 concentration of calcium hydroxide. What was the concentration of HCl in the original solution? The problem says we are going to take a solution of hydrochloric acid with an unknown concentration and add it to a solution of calcium hydroxide with a concentration of 0.157 concentration. The acid HCl is added to neutralize the base calcium hydroxide. We are going to use this information to find the unknown concentration of hydrochloric acid in the original solution. So the question is, what is the concentration of hydrochloric acid in the original solution? We are going to draw a picture or diagram illustrating the concepts in this question. This helps us to formulate a clear solution. This is helpful because if you can convert the words of a problem into a diagram, you can solve any problem. Let's make a picture step by step. Calcium hydroxide comes apart completely into ions because it is a strong electrolyte. There is 1 mole of calcium for every 2 moles of hydroxide. We are going to add 75 milliliters of hydrochloric acid with an unknown concentration to the solution. So now we will draw an aqueous solution of HCl. HCl is a strong electrolyte, which means it truly dissociates in water. We are going to take the hydrochloric acid solution and pour it into the calcium hydroxide solution. Another step into solving the problem is to write a balanced chemical equation. The balanced chemical equation is 2HCl plus calcium hydroxide yields 2H2O plus calcium chloride. The hydrogen atom bonds with the hydroxide to form water, and the chloride atom bonds with the calcium to form calcium chloride. Since we drew this diagram, solving the problem will be a lot easier. We can now refer to the picture instead of the words in the problem to understand what is happening. The next step is to ask yourself, what do I know about the given information? We know that we have 75 milliliters of HCl and that we have 27.3 milliliters of calcium hydroxide and 0.157 concentration of calcium hydroxide. We know to find the concentration of HCl, we can use the formula M equals moles of HCl over the volume. To find the moles of HCl, we will use the moles of calcium hydroxide and the stoichiometry in the balanced chemical equation. We will use the 2 in front of the HCl and the 1 in front of the calcium hydroxide. But before we begin to solve the problem, we have to convert volume of both solutions from milliliters to liters. So you can see that 75 milliliters of HCl equals 0.075 liters of HCl, and 27.3 milliliters of calcium hydroxide equals 0.0273 liters of calcium hydroxide. Now we will solve the problem. First, we will find the moles of calcium hydroxide. To find moles, we will use the equation moles equals concentration times volume. So moles of calcium hydroxide equals 0.157 concentration times 0.0273 liters, which equals 0.0042861 moles of calcium hydroxide. We will now use the moles of calcium hydroxide and stoichiometry to find the moles of hydrochloric acid. We start with 0.0042861 moles of calcium hydroxide, and we use the mole-to-mole ratio to find that there are 0.0085722 moles of hydrochloric acid. Now to find the concentration of HCl, which is what we are asked to solve for in the given problem, we will use the equation concentration equals moles over volume. So concentration of HCl equals 0.0085722 moles divided by 0.075 liters of HCl. So we now know that the concentration of HCl equals 0.114296 concentration. Now we are going to look at some common mistakes that people make during titration problems. The biggest common mistake is forgetting that the moles of HCl can be found from using the moles of calcium hydroxide by using stoichiometry. Be careful not to use the equation M1V1 equals M2V2. Another common mistake is forgetting to convert the volumes of the solutions from milliliters to liters, as you can see here.